group of instructions which we talked about in the previous lectures is moving an immediate value and a byte to one of the registers or a memory location with the address in the HL register pair. So the opcode for all of these 8 instructions is this one. 00110 is common in all of them, and XXX again is defined by the table that we talked about. For example, A, the value for the A is 111. So if we divide them, this would be 3 and this would be E. 3E is the opcode for moving a value in the A register. As an example, let's say we have this memory here, this memory cells, and we have written, the programmer has written the value of 3E and 1A, and the PC is pointing to this location. So 3E would be brought inside the IR register. The CPU would find out that the byte in the next memory cell should be read and put inside the A register. So we say the steps taken for this would be a fetch and one read. All of the other 6 would be the same thing until this last one, which is move IM byte. And well, obviously the opcode would be 1 byte, and the byte also here would make the instruction a 2-byte instruction. The steps or machine cycles for all of them is FR until move IM a byte, which would be 1 as the fetch. Then, well, obviously we need to choose the memory cell, meaning the value of the byte should be first read inside the CPU, right? So we have another read here after the opcode of the M. First of all, the opcode for here would be, well, the value of M is 110, so we would have 00110 common in the instruction. Then XXX would also be 110. This would be 6 and this would be 3. 36 is the opcode for move I something, M, and 1 byte in the memory cell. So this value, the opcode would be first read, which is the fetch step. Then another read would read the byte following the opcode in the RAM. After that, we know that we need to write that byte in the memory location that has been chosen by the HL register pair, meaning the value in the HL register pair has been put on the address bus and the memory cell has been chosen. Now the value that has been read and put on the data bus would be written inside that memory cell that has already been chosen by the value on the address bus. So we say the last step would be a write. So we have 3 steps or 3 machine cycles, 1 step more than the other 7 instruction. Next we get to these 4 instructions, which are 2 bytes would be read inside one of the register pairs, and we talked about this previously as well. Obviously this would be 3 bytes because 2 bytes would be this double and 1 byte for the opcode. The values, this would be the BC register pair, this is the DE register pair, HL, and finally the SP, which is a stack pointer, and we'll talk about it later. Now let me tell you something about this. The opcode is 00XX0001. Why XX? Because we have 4 instructions of this kind, so we only need 2 bytes to represent all of these values, and it would be exactly in this order. Using 2 bytes, we could say that this would be 00, this would be 01, this would be 10, and this instruction would be 11. So the instruction for this would be 000001, and the 2 bits would be 00. The next one is 01. LXID double, the opcode for it would be 000001 is common, and the XX would be 01. And then the next one obviously would be 00100001, and lastly we would have 11. In hex this is 01, in hex this would be 11, this would be 21, and this would be 31, the opcodes for all these 4 different instructions. Well, obviously if we want to talk about the steps or machine cycles taken for all of these instructions, we would say we'd have 1F for the fetching the opcode. As an example, we have fetched the 0, 1 value, and we talked about all the exact steps. It's just then we get to the double, which would be 2 reads, and that would be put inside one of the registers. So it would take 3 different machine cycles.